everyone. So today I'll be going through this exercise 7A. Just take note, this is from the Think Emath book. So it's different from the Discovering Math book. So there are two versions of textbook out there lah. So I'm just going to go through this particular exercise 7A from the Think textbook. Okay, so I will go through using the other book lah, but not for this video lah. So this video will only contain Think Math textbook. Okay, so let's go through this question 7. So a clock tower MT has a height of 45 meters here. Okay, 45 meters here. The angle of elevation of the top of the clock tower from 2 points A and B are on the ground are 42 and 37 degrees respectively. So the angle of elevation, from A to the top of T is 42, right? And then from B to the top of T is 37. Okay, so the diagram is very nicely given, so we can make use of the diagram. So what they want us to do is to find the distance between A and B, right? So this question mark over here. So first thing first, I want, right? Let me see. Okay, I want to find out the length of AT. All right, so if you want, how to find out the length of AT? So number one, I want to find AT. Okay, so to find AT, right, the length of AT, I want to use this triangle. Okay, all right, maybe I should draw the. I want to use this triangle. So triangle ATM. Okay, and then this is a right angle triangle, and then we know TM, right? So we can actually find AT using Tuakaso. All right, so it is sine 42 degrees equals to opposite, right? TM over AT, right? So sine 42 degrees equals to 45 over AT. So our AT is equals to 45 over sine 42 degrees, which is equals to 67.2514. Okay, so just giving it, I mean, that's not the final answer, so I will definitely need to have 5 significant figures or more. All right, so after finding AT, right, now we need to find out what is our, our angle TAB. Okay, so now I want to use, okay, maybe I should draw out the diagram. So now I want you to focus on the smaller triangle, right, like this. So T, right, B, and A. So they want this, right? And then we have 37. Okay, we just found out our AT, which is 67.2514. All right, so I need to find this angle for sure. Okay, so what is the purpose? I want to make sure that I can use sine rule, right? Yeah, so for this angle here, it is actually, okay, I will need to find angle TAB lah, for sure, this one as well. So number 2, right, is to find angle TAB, and then after that, find angle ATB. Okay, so for angle TAB, right, it is equals to 180 degrees minus 42 degrees, right? Because TAM is 42 degrees. So 180 minus 42 is 138 degrees. Okay, so this is 138 degrees. And then for angle, so we should write lah, adjacent angle on a straight line. Okay, then angle ATB will just be 180 degrees minus 138 degrees minus 37 degrees, which will give us 5 degrees. So this is sum of angles in a triangle. Okay, something like that. So we know that this is 5 degrees. So now we can use sine rule to find AB. All right, so sine rule, right? So number 3, now point number 3, we can find AB already. Okay, so find AB. All right, so AB over sine 5 degrees is equals to AT, right? Yep, AT over sine 37 degrees. Okay, this is the purpose why we find AT at the first pointer. All right, so AB over sine 5 degrees equals to AT, which is 67.2514 over sine 37 degrees. So I'm going to do my workings here. So AB is equals to 67.2514 over sine 37 degrees times sine 5 degrees. And then that will give us the answer of 9.73945, and then it's 9.74 meter. Okay, so 3SF lah. Okay, so in this case, I'm actually making use of Picasso, what we have learned in Sec 2. And then also under Sec 3, right, we learn sine rule, right? So I'm making use of sine rule also to solve for the distance AB. Okay, so this is it for question 7. Okay, let's go through question 8 together. So question 8, there's no diagram. So it's very hard to do this type of question without a diagram. So of course, we must create a diagram lah. So let's read the question and create the diagram together. Okay, so a castle is located on top of a mountain. All right, and then Ali stands 55 meters away from the foot of the mountain. Okay, so let me draw the mountain and the castle first lah. It's not going to look nice, but of course, because this is a diagram, right? So, okay, so a mountain. Okay, just assume a mountain like that. Okay, and then a castle is like that. Okay, I know very squarish lah, but or rectangularish, but it's fine. Okay, then the foot is here. Okay, the foot of the mountain is here. Okay, then Ali, hold on, let me just get rid of this. Okay, then Ali, right, is where? 55 meters away from the foot of the mountain. So let's say Ali is going to be like here. So this is Ali. Okay, at this point. Okay, so Ali is here. Ali. And then this is 55 meters away from this foot of the mountain. Okay, then they say the angle of elevation of the top of the castle. Okay, top of the castle, which is here, right? This one, top of the castle. And the top of the mountain, which is here, right? From Ali's line of sight, right? So means from Ali, okay, are 60 degrees and 45 degrees respectively. So that means that 60 degree is for the angle of elevation to the top of the castle. Okay, so to the top of the castle, right? This is 60. Okay, so this is 60, and then I just going to draw to the top of the mountain also lah. Okay, just like that. Okay. Wait, let me just do it a little bit better. Okay, yeah. Okay, so wait, so 60 degrees is from the top of the castle, right? So this entire thing is 60 degrees, right, to the top of the castle. And then to the top, right, to the top of the mountain, it is actually only 45 degrees. Okay, so this is 45 degrees. Okay, good. Then after that, they want us to find the height of the castle. So they want us to find this. Okay, the height of the castle. So what do we have to do? So first thing first, let's find angle. Oh, okay, I think let's label lah. So this is A. Let's label this as A. This is B. This is C. And then Ali be just X. Okay, so Ali is just X here. Okay, so we want to find out what is, I don't know why this thing. Okay, we want to find out what is BC lah. Okay, so let's find angle ACX first. Okay, so the angle ACX, what's wrong? Okay, angle ACX, right? So angle ACX, all right, equals to 180, because this is a vertical mountain, so this is a 90 degrees over here. So 180 degrees minus 90 degrees minus 60 degrees, right, equals to 30 degrees. So we know that this is 30 degrees over here. Okay, then the next part we're going to find what is angle CXB. Okay, CXB, where is CXB? CXB is actually here, the small angle over here. I don't know whether if you can see it, but it's the small angle, the blue here. Okay, the angle here. So CXB is just equals to 60 degrees minus 45 degrees. Okay, and this is equals to 15 degrees. Okay. Okay, next, then we want to find out what is BX. we want to find out what is bx, okay, the length of bx. So for us to find out the length of bx, right, we need to use okay, let me redraw out the triangle lah. So bx is here. We are using the right angle triangle over here. So b, a, and x. Okay, then you know that axb, right, is actually 45. This is 45. Okay, 45 degrees, and then this is 55 meters. So how to find out bx, right, is what? Using what? Cosine, right? Tuakaso, right? So car, right? CAH. So cosine 45 degrees equals to 55 over adjacent over hypotenuse, which is bx. So bx is equals to 55 over cosine 45. Okay? And this is equals to 77.78174. Okay? Can? So after finding bx, right? Okay, then I know that this part is 77.78174. Okay, so now how do we find BC? Okay, so visualization again, I'm going to draw out, all right, draw out the diagram again. I'm going to draw out what you call that, the triangle BCX. Okay, so to make it clearer lah. Why cannot remove? Don't know but why something is going wonky today. Whoa. Yeah. Okay, I don't know why something is going very wrong. Okay, yeah, so some technical error, but let's continue. Okay, so I'm going to redraw this triangle CBX. Okay, so we are going to draw triangle CBX. So this is C, B, and X is like somewhere here lah. Okay, so this is X. So we want to find BC, right? And then we have this, right? 77.78174. And then we also know CXB, this is 15 degrees, right? And then we know BX as well, right? This BX is 77. Oh, wait, I think I wrote the wrong thing. So BX is not CX, sorry. BX is supposed to be 77.78174. It's not CX. Okay, so let me write here. So this is 77.78174. Okay, yeah. Then now we need to find one of it lah. Okay, we need to find the BC. Okay, so how do we find BC? We can use sine rule lor. Okay, so oh yeah, we also found out that the ACX is 30. This one is the 30 lah actually. Okay, 30 degrees. Yeah, so with this we can use sine rule already. So okay, let me change another color lah. So BX over sine 30, okay, equals to BC over sine 15. Okay, so BX, which is 77.78174 over sine 30 equals to BC over sine 15 degrees. Okay, so BC is equals to 77.78174 over sine 30 degrees times sine 15 degrees. Okay, and this will give us 40.26279. okay, which you can round off to 40.3 meter. Okay, can. So BC is actually the height of the castle lah. So the height of the castle is 40.3 meter, three significant figures. Okay, so this is it for question 8. Okay, let's go through question 11 together. So another question without a diagram. So we got to draw diagram and visualize lah. So the angle of depression of two boats, okay, angle of depression of two boats, okay, and these two boats is due west of a cliff. Okay, so we have a cliff. So imagine we have a cliff here, okay, and then let's say the water is like here lah. Okay, just going to draw a horizontal line for the water, which is a bit weird, but yeah. Okay, and then from the top right is 23. Okay, so they say the angle depression, okay, from the top of the cliff, which is like here, right, to the two boats, okay, are 23 degrees and 18 degrees respectively. Okay, so that means let's assume the boat is like here and here lah. Okay, so draw a line. Okay, let me use the line tool to draw it. Okay, so this and this. Okay, so angle of depression, so how do we draw angle of depression from the top of the cliff? So recall angle of depression from the top of a cliff, right, is always measured using the eye level, right, which is horizontal, so-called horizontal to the flat ground, or in this case, the sea level lah. Okay, so this is like the eye level. The black line is at the eye level, and then is the angle of depression is created, between the eye level to the sight, the vision, the path of vision, the path of sight of those two boats. Okay, so that means the 23 degrees is what? Must be bigger, right? So this is 23 degrees. Okay, and then this is 18 degrees. Right? So this is 23. The bigger one is 23. Let me just do like, 23 degrees. 23 degrees. Okay? And then given that the cliff is 88 meters high, okay, so calculate the distance between the two boats. So I'm just going to label this as like the top is like A, the bottom is at B, and then the one nearer is C, and then D. Okay, so they want us to find CD lah. Okay, they want us to find CD. Okay, so basically, right, if you look at the degrees, right, you can tell that, angle ACB, right, is actually 23 degrees, right? So we can say that this is 23 degrees. Okay, right? And then we also can say that this is 18 degrees. How come? Because of alternate angle, right? So this is parallel to this. The eye level is parallel to the sea level. Okay, so and what's next? So that means looking at this, right, we also need to find out what is our angle DAC, or rather CAD lah, CAD. So angle CAD is equals to 23 degrees minus 18 degrees, which is 5 degrees again. Okay, so this is 5 degrees. And we also need to find out what is our what you call that, CA or AC, the line AC. Okay, using Picasso as well, because this is a right angle triangle, right? Triangle ABC is a right angle triangle. So we want to find AC. So looking at this, it will be opposite and hypotenuse, so sine. So sine 23 degrees equals to opposite over hypotenuse. So AC is equals to 88 divided by sine 23. Right, which will give us, let's calculate this. So 205.218. Okay, so this length is okay. So maybe let's redraw it lah. So like this. Yep. So this is A, This is D and this is C, right? So 18, this is 18. 18. And then this is like 5 degrees. Then we have AC, which is 225.218. Okay, then we want to find this. Okay, so definitely we can use sine rule now, right? Yeah, so sine rule goes like this lah. So AC is over, right, sine 18 degrees equals to CD, right, the distance between the two boats, over sine 5 degrees. So we will have 222. It should be 225. So 225.218 over sine 18 degrees equals to CD over sine 5 degrees. So how to find CD? 225.218 over sine 18 degrees times sine 5 degrees. Okay, so if you calculate this, it will be sine, just give me a moment. So this is 63. Oh, I don't know why this keep popping up. Okay, sorry again. So yeah, 63.5211 meter. Okay, so if you round off this, is 63.5 meters. All right, 3SF lah. 3SF. Okay, three significant figure. Yeah. So as you can tell, the distance between the two boats is 63.5 meters. Okay. Yeah. That's it for question 11. Okay, let's go through question 12 together. So same thing, no diagram. We got to read and draw the diagram at the same time. Okay, so a satellite dish stands at the top of a cliff. So the angle of depression of a ship, so there's a ship lah, right, which is 80 meters away from the base of the cliff, right? From the top of the satellite dish is 37 degrees. So, okay, let's draw the cliff first. Okay, so a cliff, right? A cliff. Then probably the ship is like here, S. Okay, I'm just going to draw the satellite dish longer lah. So probably like that. Okay, I know it's not good. Yeah, it's like maybe the cross-section view. Okay. Yeah, so from the top, from the bottom of the cliff here, right, I label this C lah. Okay, so this is A, this is B. Okay, and the bottom of the cliff is C. So from C to S is 80 meter. 80 meter. So that's what they said. Okay, then they say the angle of depression from the top of the satellite dish is 37 degrees. So same thing, draw a horizontal line, okay, the so-called the eye level horizontal line, okay, and then you draw it downwards towards the ship. Okay, so this is 37 degrees. Okay, and then also the angle of depression of the same ship, right, from the foot of the satellite dish, which is at B lah, is 32 degrees. So same thing, horizontal level, eye level, right, and then you draw a line downwards to the to S lah. Let's draw it nicer, to S. Okay, so this part is 32 degrees. Yeah. Okay, then lastly, they want us to find out what is the height of the satellite dish, which is find AB lah. Okay, so we got to find AB. So first thing first, okay, we got to find AB, right? So we got to find several angles lah over here. Mainly, yeah, quite a few angles that we have to find. Okay, so let's find this angle first. Okay. You know what? Let's find, okay lah, we do step by step lah. So number one, let's find BAC. So BAS, sorry. So angle BAS, right, which is here, right, is equals to 90 degrees minus 37 degrees, right, which is 53 degrees. Okay, so this is 53. Then same, we find ABS. Okay, so ABS is this entire angle here. It's actually 90 plus 32. So ABS is equals to 90 degrees plus 32 degrees. Okay, so 122 degrees. So yeah, this is 90 degrees. Okay, so the whole thing is 19. 122, sorry, 122 degrees. Then angle ASB is equals to 180 degrees minus 53 degrees minus 122 degrees, right? Which will give us 5 degrees again. So this is 5 degrees. Okay. And lastly, CBS, angle CBS. Do we really need CBS? I don't think so lah. Oh, okay, yeah, we need, because we need to find BS. So angle CBS is equals to I can do 90 degrees minus 32 degrees as well. So it gives us 58 degrees. So this is 58 degrees. Okay. So the next thing we need to find out what is our BS. Okay, so BS, so to find out what is BS, we need to look at the right angle triangle CBS. Okay, so CBS is the right angle triangle. So we need to find BS, right? So that is actually the hypotenuse. And then 80 is the opposite. So sine 58 degrees equals to opposite, which is 80, over hypotenuse, which is BS. So BS is equals to 80 divided by sine 58 degrees, right? So this will give us 94.33427. Okay, so after finding out BS, maybe, okay, now the diagram is a bit messy. Why? Because there's a lot of angles going on there. So let me draw out the triangle again. So something like that. Okay, I know it doesn't look like a triangle, but let's make do with it. So A, B, and S. So we know that BS, this is 94.33427, and then this is 5 degrees, right? And then this thing over here, this is 53 degrees, right? Yes, okay. So we can use sine rule again, right? So let me change another color. So BS, okay, so BS, maybe I should write on the left. Okay, so BS, right, over sine 53 degrees is equals to AB over sine 5 degrees. Okay, so BS is 94.33427 over sine 53 degrees. Okay, and is equals to AB over sine 5 degrees. So AB is just 94.33427 over sine 53 degrees times sine 5 degrees. So this will just be equals to 10.29477, and then you can round off to 10.3 meters. 3 significant figure. Oh, yeah. Okay, so the height of the satellite dish is 10.5. Yeah. Okay. 10.5. Sorry, my bad. The height of the satellite dish is 10.3. Okay, I written here 10.3. It's not 10.5. Yeah. Okay, so that's it for question 12.